Welcome to this fabulous edition of Comet Algebra. I know we're all so excited to be here. This video is for Chapter 11, Section 4, entitled Verifying Identities. Now, before we get started on the material in this section, we need to look at another way of stating the location of points like this on the unit circle. So we're going to have another way to talk about this point A right here. If this is drawn as a 30-degree angle, we learned in the last chapter that we draw in the perpendicular here, and we know in the unit circle the hypotenuse is 1, and then we calculate that the short leg is half the hypotenuse, so this leg is 1/2, and the long leg is the short leg times the square root 3. And we learned that the location of A is this x and this y. Well, let's just look at that a different way. So starting here, the location of A, the old way we did it, the x is square root 3 over 2, comma, and the y is 1/2. All right, that's your previous knowledge. So now let's look at another way to write this location. If I asked you a question, what is the cosine of 30? You'd come over here and you'd see the 30 and you would go adjacent over hypotenuse. So adjacent over hypotenuse, square root 3 over 2 over 1 is just square root 3 over 2. And then if I asked you what is the sine of 30, you would say opposite over hypotenuse, or 1/2. So let's look here now. Do you see that this x-coordinate is the cosine and the y-coordinate is the sine? So, like I said, this is something, just a new way to look at it. You knew this, but we never looked at it from this point of view before. Therefore, the conclusion we can come to is that the location of A is cosine 30, sine 30. And I want you to know how to pull these off of, I gave you a blue sheet with the unit circle with all the endpoints that you know, and the new way of looking at it, like I said, x is the cosine of the reference angle and y is the sine of the reference angle. So the way I remember this ordered pair, whatever the angle is, I'm just going to call it x, cosine x, sine x is the xy coordinate, and I just remember it because it's alphabetical. C comes before S. All right, these notes here are really restating something that we did earlier in section 3 of this chapter, but we'll go over it again. We're going to be asked to verify identities, and to do so, one strategy is you just start with the more complicated side and you work with it, making substitutions, easy for me to say, or doing your algebra, and you work with it until it matches the other side. The other method is you can do some changes to both sides until they match. Both of these are fine. This one, the second one, you have to watch out. You have some limits. You can do changes to both sides, but one thing I do not want you to do is do not square both sides. Don't square both. There, I can write. Because if you square both sides, you introduce the plus minus, and that can bring in some extraneous solutions, what we called garbage answers. And the other thing you have to be careful of is what you're dividing both sides by. You don't want to divide both sides by something that could equal 0. So don't divide both sides by 0. Because remember, both sine and cosine are 0 at different degrees. And so we just have to be careful when you're dividing both sides. So to be on the safe side, I recommend this one. If you are working in the simplifying direction, you're not going to have these problems. And of course, we used these strategies in section 3. We substituted from previous identities that we've already proven. We learned that we have to change those Pythagorean identities once in a while. We have to subtract a sine from both sides or cosine and manipulate them. This one I highly, highly recommend. If you're working on an identity in this section and you're just stuck, if you have other trig functions, just move towards sine and cosine by doing your substitutions. Very, very often this will lead you to simplifying and getting where you want to go. And of course, we used all our algebra skills: distributing, factoring, foiling, canceling, combining like terms. This skill is really handy to multiply a fraction, to multiply by a fraction equal to 1. That could be like multiply by cosine over cosine when you need a cosine squared or you need common denominators. So that's very useful to remember. In this section and in the next section, we are continuing working down our list of identities on the pink sheet, and we're proving them. So the next ones on the list here are the negative angle identities. And these are not very difficult to prove, so we're just going to walk through it together. So here I have the unit circle. This angle coming up is positive theta, and this angle coming down from the initial side is negative theta. So if we looked at the triangles that are formed, I'll try to draw this in as straight as I can, but anyway. So there's the perpendicular. And now the question we're asked is, what is the cosine of theta? Well, this side is just x. We don't know what it is. Coming up this side is y. And since these angles are equal, this side would be x again, and coming down here would be negative y. So let's use those as we answer these questions. So the cosine of positive theta would be adjacent over hypotenuse, so x over 1. So this is just x. And the cosine of negative theta, okay, coming down here, is adjacent over hypotenuse, x over 1, which is just x. So using our diagram here, we just proved this first identity. We just proved that the cosine of negative theta is the same as the cosine of theta. And the way I remember that is in cosine, the negative sign doesn't matter. But something different happens with the sine. Same thing here. If we look at the sine of positive theta, we have opposite over hypotenuse, which is y. Sine of negative theta is negative y. So in this negative angle identity, the sine of negative theta is the same as negative sine of theta, that you have to keep the negative sign. All right, so now we can check that off the list. We've proven the negative angle identities, so now we can use them in our work. All right, all we have left now is to do 3 examples using what we've learned. Again, when you verify, you're going to have both sides. You're going to be given what you're starting with, and this is what you need to end with. And that's why I said start with the more complicated side, do some simplification, and try to end up with the easier side. So looking at what we have cosecant squared and 1 minus cosine squared. Now, when I see this, right away, I think of the Pythagorean identity, and I know I can move this towards sine, and of course, 1 over cosecant, 1 over sine is cosecant, so we can move both of these things towards sine with the thought that maybe we'll get some canceling, and then it can equal 1. So I made the 2 substitutions, that cosecant squared is 1 over sine squared, and 1 minus cosine squared is sine squared, and then when you multiply these two, they cancel, and we do get 1 equals 1. So that's verified. All right, now we are asked to prove that these two messes are equal to each other. Looking inside the parentheses, I'm not seeing an identity that I can make a substitution. So I'm going to go ahead and distribute this and multiply here because I just don't know what else to try. So it's okay if your attempt leads you to a dead end. We have to try something. So cosine x times tan x minus cosine squared And I'm just going to keep working with this side and see if I can get it to look like this side on the right. Now I have these in cosine. I want to do the substitution for tangent. Tangent is sine over cosine. And then doing some canceling here, the cosines cancel. So I have sine minus cosine squared x. So this is what I have. And then I'm looking at what I want. I have one piece of it. I have the sine x. So now I'm looking at cosine squared and thinking that I want sine squared and I want a 1, and that would lead me to the first Pythagorean identity. And so I can make that substitution, but I do need to watch this negative sign here. So I subtracted a sine squared on both sides on that first Pythagorean identity, so I can substitute cosine squared and put in 1 minus sine squared. And then if I simply distribute this negative sign, I have it. I have sine x minus 1 plus sine squared x. It's the same thing as the side on the right, just a little different order, so I could rearrange it. All right, next example. We are asked to prove that this mess is equal to tangent. And so again, I'm going to start with the more complicated side, do substitutions and simplifying, and try to get to the tangent. Since I'm not seeing any identities at all in this numerator, I'm just going to take the advice of that one strategy that says move towards sine and cosine and see if it works for you. So let's substitute everything in this first fraction and move it towards sine and cosine. So I made the substitution, cosine over sine for the cotan, and I put in sine over cosine for the tangent, and 1 over sine squared for the cosecant squared. And this may look like a mess with a compound fraction, but I'm going to try this strategy and see if I can get towards this tangent. Now I have these two fractions in the numerator, and I'd like to be able to add them, so I need common denominators. If one denominator is sine and one is cosine, the only common one we have is sine times cosine. So I'm going to multiply this first fraction, cosine over cosine, and I'm going to multiply this fraction times sine over sine. And let's write our equivalent fractions now. So here are the equivalent fractions with their common denominators. So now I can go ahead and add them. So I have sine squared x plus cosine squared x all over my common denominator of sine x cosine x. And of course, this is still all over that denominator of 1 over sine squared. Now, it might not look like we got anywhere, but I hope you recognize this top numerator here as an identity. This is 1. So now I have 1 over sine x cosine x. And remember, we don't divide fractions. If we're dividing by this 1 over sine squared, with fractions, you multiply by the reciprocal. So I'm going to flip it around, 1 over sine squared, sine cosine, times sine squared x over 1. And this sine cancels out one of these, which leaves me sine over cosine, which is equal to tangent. So we proved it, we got to the tangent. All right, have fun with section 4.